Hello, this is FlippedHarber for Precalculus. In this video we're going to cover section 5.2, Trigonometric Functions, Unit Circle Approach. Our objectives for this lesson are to find the exact value of trig functions using a point on the unit circle. We're going to take a look at finding the exact value of some trig functions at some important angles on the unit circle, what are referred to as the quadrant angles, 0, 90 degrees, 180 degrees, 270 degrees. We're going to take a look at the exact value for 45-degree angles, 60-degree angles, 30-degree angles, and finally we'll use a calculator to approximate the value of the trig functions. Here's our outline for the video. We'll start by talking about the unit circle, what the 6 trig functions are in the unit circle, finding the value of those trig functions. We'll take a look at how to evaluate some trig functions. We'll find some exact values, and then we'll end with that calculator use. Alright, so first of all, let's talk about what the unit circle is. It's really simply a circle centered at the origin with a radius that's equal to 1. So the equation for this circle from algebra would be x squared plus y squared equals 1. Angles measured from the positive x-axis going counterclockwise is what we'll be working with. So I've marked one on here, the angle theta, and that's our normal name for an angle, is theta. Now, for every angle theta on the unit circle, there's a point that we're going to talk about, x comma y. So basically, every distinct angle has its own set of points on the circle. Remember, x squared plus y squared has to equal 1 no matter where we're at on this circle. So you should probably already be familiar with at least 3 of the 6 trigonometric functions. You did talk about this in geometry. Those 6 trig functions are the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. Now, on the unit circle, we can find our trig functions of the angle theta in the following way. The sine of theta is just equal to the y value. The cosine of theta is equal to the x value. Tangent is equal to the y value divided by the x value. The cosecant of theta is 1 over the y. Secant theta is 1 over the x. And the cotangent is x over y. So you see that there's a few reciprocal relationships here. We'll be talking about that later in the chapter. Now, if we want to find the value of the 6 trig functions on a circle that's not the unit circle, it's still centered at the origin, but instead of the radius being 1, the radius is just some value r. Here's how we find those 6 trig functions. Now, if we want to find the 6 trig functions of any angle, regardless of whether it's a big circle, a little circle, or even if we just want to find the value for an angle out in space, they all have the exact same value. If you find the 6 trig functions on the unit circle, or on a circle with a radius of 2, you're going to find out that it works out to be the exact same thing. No matter what circle we're using, or even if there isn't a circle involved, the tangent of 30 degrees is going to be the tangent of 30 degrees anywhere. Now, we're going to start by looking at some exact values for the 6 trigonometric functions of the quadrant angles. Those are basically pointing straight to the right, straight to the left, straight up, straight down. 0 degrees, 90 degrees, 180 degrees, 270 degrees. Now notice this unit circle is also marked out in radians. 0, pi over 2, pi, and 3 pi over 2. You're going to get very familiar with how angles fit in their degree measure and in their radian measure. You're going to get very used to the fact that pi over 2 and 90 degrees are the same thing because we're going to use them so much. Now, here is a really small trig table. Now, I gave you a bigger trig table in class, and basically this is when you would start filling it out. You would want to write all of these values into your trig table that I gave you. Now, if we look at it for some more angles, 30 degrees, 45 degrees, and 60 degrees, or in radians, that's pi over 3, that's supposed to be pi over 6, pi over 4, and pi over 3. here they are. Again, basically you just want to write these into the trig table that I gave you in class. Now, when you're using a calculator to find trig values, you're always going to get an approximation, unless you've got one of the really fancy calculators that will actually spit it out as a nice, neat fraction with that square root. It's going to spit it out as a decimal. But really the trick here is first make sure that your mode is right. Make sure that if you're trying to find the trig value for a radians angle, that your calculator is in radians. If you're trying to find some trig value for an angle in degrees, make sure you're in degrees. Now remember, if you don't see the degree symbol, then it's in radians. We don't really use a unit on radians. So if you see the little circle, it's degrees. If you don't see the little circle, it's radians. Now that's with or without the pi. The pi is a sure tip-off that it's in radians. But I could talk about an angle of 1 in radians. That's fine. You're just looking for the lack of that degree symbol. Now really, for sine, cosine, and tangent, you just type the darn thing into your calculator. So here, I've got a screen cap for a calculator where I found the sine of 2 pi over 5. So obviously I went in, made sure that my calculator was in radian mode, and I typed it in pretty much like it would look on paper. I used 2 times my pi symbol, and I used my divide key for my fraction bar. 5, I close my parenthesis. Now I could have skipped that last parenthesis, but it's really good habit to stay in to close that off. And here I get a nice approximation for the sine of 2 pi over 5. Now that's for sine, cosine, and tangent. Things are obviously going to get a little more difficult because you'll notice nowhere on your calculator is there a cosecant, a secant, or a cotangent button. So what we need to do is actually go 1 divided by sine, 1 divided by cosine, and 1 divided by tangent. So here's a relationship that we're going to get very used to. The cosecant is 1 over the sine. So if I'm asked to find the cosecant of 2 pi over 3, that's not built into the calculator. I'm going to go 1 divided by the sine. Again, good habit to get into to close those parentheses and get our decimal approximation here. Alright, so that's not too bad. You're going to have to do some problems in the homework where you're finding the value for trig functions. More often than not, you're just looking it up in your table. You might have to add a couple trig values. Again, not that big of a deal. Turn to your trig table, get the numbers, and add them up. Alright, so I'll see you in class, and I'll see you in line.